Hi. Um, First of all, I want to say I apologize that this recording is coming late. This is recording for my project for E473. The title of my project was um a comprehensive literature review on natural language processing, applications of deep reinforcement learning. The idea is to um, review all the most of the literature or some important literature in that have to do with how deep reinforcement learning has been applied in natural language processing. And natural language processing, as you know, is like this it's this big thing now because of the advent of ChatGPT, Bard AI, Bing Chat, and other large language models and transformers that are doing very cool stuff with language. So I wanted to really delve into like how is ChatGPT being used, how is deep reinforcement learning being used in all of these, really cool um LLMs and transformer based networks. So pretty much I divide the entire review into two parts, where it's an exploration of deep reinforcement learning in NLP, and then I evaluate like what are the algorithms that are being used in deep reinforcement learning in NLP. So I'll start by how I did my methodology. So pretty much the whole idea was to I was able to like scrape from the ArcV database, the archive. They have a API. So I'm able to call that API using this code. And I'm able to query like all the papers that have, as you can see here, all the papers that have deep reinforcement learning and natural language processing. And then I'm able to get all those papers for the last 10 years. And then out of those papers, right, I extract their summaries. And then from the summaries, I'm able to infer what was the deep reinforcement learning method used. As you can see here, right, we get the deep reinforcement learning method used um, using this code. And this code is in the report that I wrote. So it's going to be clear just by looking at it. So it says prompts, deep reinforcement learning method used. We use ChatGPT to, kind of read the summary that we get from archive and extract what the method was, a rough idea of what the method was. And for some, we didn't get the method was from the summary, and we just discard those ones. So we were to come up with like 31 papers, about 31 papers from the last 10 years that we're able to get like a method used from them, and from the summary of those papers that we got from the archive. Um, and I I then did like a logical categorization of these papers um, based on the deep reinforcement learning method used. So these were the logical categories and some important papers under each of them that I thought were insightful. It was based on this analysis. Okay, we can separate all the methods for that were used in all these NLP related papers into these categories. That we then I then said, okay, what are the top two categories, right? And we deciphered that, okay, there's the most popular categories were value-based methods, policy-based methods, um, and, despite the other categories. And so like I focused on these two categories, did a case study in one category, did another case study in one category. And then for the lowest category, I then said, oh, why is this category not, so popular? And then I was able to derive a few ideas just by scanning the literature as to why this particular method, which is the one where you're actually creating the model from scratch, just model specific, right? It's like yeah, model based. So you're creating a model of the environment from scratch. Um, and no paper actually mentioned that. And so, yeah. So first of all, like I do a clear, make sure I give a clear distinction, like to the reader, as to what value-based methods are, policy-based methods are. I will not go into details of that because this is supposed to be a 5-minute video. Then I do the 2 case studies, one from Lee et al., which is deep reinforcement learning for dialogue generation. In that paper, they have this, architecture where they have an encoder and a decoder that are talking to each other, and they're training on a set of rewards. Because it's policy gradient based, they're doing a optimization of the policy function based on these 2 rewards. Based on these 3 rewards. So they have 3 rewards, one that's forward looking. Each of the rewards has like something in language and communication that it kind of, mirrors, that it kind of, conveys. So we have the one that's forward looking to make sure that this thing is not just saying things that are not, continuing the conversation, that are not stopping the conversation. Because the problem that we're having in this, before they introduce reinforcement learning, is this, the AI would just, stop, like just, get secular, just start, I don't know what you're talking about, which is dismissive, right? So we're looking for things that are forward looking, and we have this function to mirror that. And I explain how that function works. I explain how the informativity function works. Like we're measuring how much information that the algorithm, the architecture that we have is introducing into the conversation. And then we have a coherence one that makes sure that, what it's saying is kind of related to, the conversation. And these are the rewards that we use to, train to do our gradient descent on our policy function. So we're technically optimizing the expected future reward while we change our policy function based on the expected future reward. So that's that paper. And then the second paper that we review here is He et al., which is deep reinforcement learning with a language with a natural language actual space. So the idea here was to play a few text-based games using some network, and they found that this deep reinforcement relevance network that actually finds if it creates speech that's and measures it based on the relevance to the conversation. And the structure of that is this. So it has 2 arms, 2 deep neural networks, and then an interactional function that is able to use what comes from the 2 deep neural networks. One of them is giving you the state, the other one is giving you the best action, and then it uses a dot product to find a measure of the relevance of that action to the state. So here's the because this uses Q-learning, because we did the first one that we did was a policy-based one. This is a value-based one, and it uses a Q-learning algorithm, which we have an idea of how that works. Like it's changing this table that it keeps of values that you get when you take an action, and it's trying to maximize, of course, the same thing, the expected reward of that table, and then it uses that table to decide what actions it takes at any point and any time. And then we show like how that performs compared to other models, the reason why the DRN converges to a better solution for the Q-learning algorithm. So yeah, we also we have a lot of other things that we talk about, like why that model, the model-based reinforcement learning methods, are not very popular, like how it's difficult to model language, and how composition is expensive. We also talk about other challenges that are affecting the field, like the fact that efficient and practical design of the action space, state space, and reward functions is not easy, and the trade-offs between exploration and exploitation. And then, yeah, we conclude, and I give all the references I use. Thank you so much.